In this problem, we'll start thinking about crumple zones on cars and how they might help save your life. In this problem, a car hits a tree and it decelerates by having the front end of the car crush in by about 0.8 of a meter. Here's a basic picture of what's going on. We have our car approaching a tree at 90 kilometers per hour. And let's just pause here and convert 90 kilometers per hour into meters per second. So 90 kilometers, there's 1,000 meters in every kilometer. Every hour is 3,600 seconds. And so that gives me, canceling the units, 25 meters per second. Now during the crash, the car hits the tree and the front of the car crumples up by about 80 centimeters or 0.8 of a meter. And so that absorbs some of the shock. So the car is compressed by about 0.8 meters. Now we want to calculate the acceleration, and so acceleration is delta v over delta t, which is the final velocity minus the initial velocity over the time interval. The initial velocity is 25 meters per second. The final velocity will be 0 because we'll have stopped, and the delta t is something that we don't know, so we're going to need to calculate that. Now to do that, we're going to need to find an average velocity. The average velocity is distance over time, and that means that the time we're looking for is the distance over that average velocity. The average velocity, we're just going to use the numerical average between the initial velocity and final velocity. So we add them together and divide by 2. So that's 0 plus 25 meters per second divided by 2 gives us 12.5 meters per second for the average velocity. Now if I just plug that in, I'll have a distance of 0.8 meters divided by an average velocity of 12.5 meters per second, and that gives us a time of 0.064 seconds, about 64 milliseconds, pretty short time. So now I can calculate that acceleration. It's equal to 25 meters per second divided by 0.064, or it is 391 meters per second squared. So that's my acceleration. And I wanted that in terms of g, the acceleration of gravity on Earth. So if I divide that by 9.8, I get about 40 g. So the acceleration we experience is about 40 times that of the acceleration that we would feel if we were just jumping off a building or something. So the crumpling of the car is just one element in reducing the acceleration that we feel. For our safety in cars, we also need things like seat belts and airbags to further reduce that acceleration.